Okay, in the last tutorial, we saw that the name of any function holds the address of the function in runtime. So if we print the name of any function, we get the address of function where the function gets loaded in the primary memory. Now, we can declare a function pointer in order to store that address. So function pointers are meant to store the address of function. So let me show you how we can declare a function pointer and how we can store the address of a function in the function pointer. The benefit of having function pointers there in our program is that using function pointer, we can make a call to the function. Now there are situations when the name of the function may not be available in the context, or the programmer may not decide that which particular function will be called in execution. So in all such situations, the function pointers are going to be helpful, and I'll show you with an example how they are helpful just after this. So for the time being, let's understand how we can declare a function pointer. So in order to hold the address of this particular function, print msg, I'll declare a function pointer there. And at the beginning, you may find it a little bit weird, okay, the declaration, but it's not that much hard to understand. So here's the declaration of a function pointer. So it tells that P is a function pointer that is capable of holding the address of all such functions which returns nothing, that means void, and receives nothing as parameter. So we can use this pointer P in order to store the address of this print message function, because that returns nothing and receives nothing as parameter. That fulfills the contract. So here we go. I'll just store that. Just P equals print msg. And print msg, as we know, that contains the address, right? So that is assigned to P right now. Now, if I have some other function there, say fun, and say it contains another message, it's all fun, and I want to store that address as well in P, I can do that. So because that fun also returns nothing and receives nothing. So P is capable of storing the address of fun as well. Now, if I want to make a call to the print message function, I can do that using P, and that's the benefit of having function pointer. You see that I'm making a call to the function at line number 21 using function pointer P. So P is going to make a call to the print msg function, because right now P holds the address of print msg function. So without using the name of the function, I'm able to call a function using the function pointer, and that's the benefit. So if I make another call after assigning fun to P, here the function fun is going to be called, but here function print msg is going to be called. Let's go ahead and see this. See that first time hello world is printed there. So print msg was called, and then it's all fun. That's from the fun function. Now, if we have some other function like this, say integer sum, integer a, integer b. So this sum function is straightforward. It receives two integer parameter and returns the sum of these two parameters, return a plus b. And we want to store the address of this function sum in a function pointer. Then it's simple. First the return type, then within parentheses star s. This is the identifier of the function pointer. Okay, and this star indicates that this is a pointer. Now you just cannot omit these parentheses. Okay, this is going to be illegal. If you do something like this, then the compiler is going to understand s as integer pointer, because this will be associated like this with integer type. Star will be associated with integer type. So it's going to be actually integer pointer, and that's going to be error, because these things are going to generate error in that case. So while declaring the function pointer, the identifier should be attached with the star or asterisk. Then comes the parameter types. They should be within the parentheses. So here s is a function pointer. So here we are telling the compiler that s is a function pointer and is capable of holding the address of all such functions which returns an integer and receives two integers as parameter. So it's actually capable of holding the address of the sum function, because the sum function receives two integer parameters and returns integer. Now I can make a call to the sum function using this s, and let me do that. And I will receive the return value, that's the sum in result. Let me print the result there. Sum is %d. Okay, so let's go ahead and run this program. So here you can see sum is 40. So we were able to call a function using the function pointer without using the name of the function. That's important. Okay, let's now go ahead and declare another function pointer there. This time, this pointer is capable of holding the address of all such functions, which returns a float and receives one integer parameter and one float parameter. The first one is integer and the second one is float. So that's the declaration of the function pointer fptr, which is capable of storing, as I said, the address of all such functions, which returns a float and receives two parameters. The first one is integer, the second one is float. Now, if the first parameter is an array, then you can just do this. So that means fptr is a function pointer and it's capable of storing the address of all such functions, which receives two parameters. The first one is an integer array, the second one is a float, and it returns a float. So that's it. I hope you have understood how we can declare a function pointer in our program. And in the next tutorial, you'll understand how we can use this function pointer in our program. Thank you for watching this.